Alright, friends and neighbors, welcome back to another networking video. Today we're going to go a little farther into our VoIP infrastructure, specifically our VoIP SIP infrastructure. We're stuck with my office background here again, so sorry about that. But anyway, let's get started. So this is what we were looking at previously, right? We did a free PBX build. We had a couple of LIN phone soft VoIP clients that were configured for SIP. And then we were doing some web interface for management. And we did that all in VMs. Well, now it's time to expand our thinking a little bit. I mean, it's pretty straightforward to build a couple of soft phones and then manually configure them. But of course, the real world doesn't operate that way. And so we need to think a little harder about, what our infrastructure looks like. So what about our production builds, right? So the VoIP clients can be either computers, like the LIN phone soft client, or the Avaya soft client that I have on my laptop right now, or standalone VoIP phones. Now the minute you're standalone VoIP phones, like, this one right here, right? So this is a Cisco 7961. So the minute we have something like that, well, we have other things to worry about. Now, when you buy a phone, you have to think about how is this going to be plugged into the network. Well, a lot of them come with a power injector. Well, those are clunky. They have to be close by the phone usually and require an extra outlet. So what we almost always do is we set up power over Ethernet. So that means that we're getting power over Ethernet from the switch. Now there are a whole bunch of issues associated with that, but let's start with the two standards, 802.3AF and 802.3AT. Now AF is the older standard, 15.4 watts, and if you have a PoE switch that does 15.4 watts or 802.3AF, you're probably okay on your VoIP phones, but I'm going to put a little asterisk next to that one. AT is for things that require a higher draw. And there's some instrumentation, some telemetry sources, but also high-end access points with lots and lots of radios in them require more power. Now, when we're talking about a switch, you might have a brand new switch that does 802.3 AT, but what you have to be aware of is how many ports that's going to provide power for, or at least how many ports at full power. So you can very quickly get into a power deficit with your switches. So be wary that you don't hook too many things to your switches. Okay. Now in addition, phones are not manually configured. If I have a whole bunch of these, like this Avaya 4610, well, if I have a whole bunch of these, I am not going to run around manually configure them like we did with the LIN phone soft clients. The most common way that we use to do this is to use DHCP to give out the IP addresses, but we're also going to give out TFTP server and a VoIP server of some kind with DHCP. So our process goes something like this. You DHCP, then you TFTP, and that's true across a lot of vendors, and then you're going to connect to the VoIP server. So how do you learn about the VoIP server? Well, we got a couple of ways we can do that. You can manually configure it on a phone. In the same way that we did the soft client, you can manually configure the phone itself right through the phone interface. So you could do that, but again, that's kind of clunky. Another common way that we have is with a TFTP file. So if you're doing Avaya, for example, you might download the information about the server and also lots of other configuration items for the phones via something called the 46xx settings.txt file. Now that's just one example, but the point is that you're bringing a text file across to the phones from a TFTP server. Now another way to learn about the VoIP server is with actual DHCP options. So instead of getting the information from a TFTP server, you get information from a DHCP option, and then either go out to the TFTP server or you go out to the call server and download your phone configuration. And that's really how Cisco does it with Skinny. So if we're learning about a phone server from DHCP or a TFTP server from DHCP, the primary options that we're going to worry about are 150, 66, and 176. And we'll see some examples of those here in a minute. But for right now, let's take a look at some captures. Now this particular capture is a SIP phone from startup. So maybe what we'll do is we'll do DHCP or TFTP or SIP. And that's all that we care about for right now. All right, now we can see that we're starting up with DHCP here, and this is the standard DORA conversation that we see at the beginning, right? Discover, offer, request, and acknowledgement. And if we take a look in the offer, I can see option 176 in this particular case. And so option 176 is telling me where my call server is. Now this is just a text string that's interpreted by the DHCP client. Now also in this string is the TFTP server. So the next thing that we see is the TFTP server, right? So we got DHCP first, and then we have TFTP. And then one thing we can see this happens to be in a VIA topology. So this could be SIP or it could be H.323. It doesn't really matter. But the point here is that we're supporting the phones. And so now we go 46XX upgrade. So in this particular case, what's happening is that we're pulling down this upgrade file, and what this is going to do is automatically go through to see if you have the latest and greatest configuration for the phone. Now that might be that you are checking your signaling protocol, whatever you're going to use. It might be that you're just checking to see if you have the options for the phones. And we can see that there's a lot of TFTP stuff that goes on, and then we drop into SIP. And then, of course, the next thing is that we're going to register. Now that is the first thing that you see when you do SIP. So once you have your configuration file across there, you'll finish that process, and now it's time to start going into VoIP. So again, DHCP, TFTP, and then into whatever your VoIP signaling protocol is. In this case, we're talking about SIP. So we have a register, we swap some options information, and then we get status of OK. So that's the back and forth there. Okay, so that's on an Avaya topology. And just for fun, maybe we'll take a quick look at the Avaya TFTP files. Now this doesn't show us very much, except that this is what the phone expects in a TFTP directory, right? Here we've got our upgrade script, right? We've got our settings file, and then here are all the bin or binary files for the phones to do their upgrading or to flash their, to do a flash upgrade. So that's all of this stuff here. So there are quite a few files that support the phones coming up. Now the funny thing is that if you're using a soft client, there's almost none of that, right? It is just straight up, I already have my SIP client, I already know what I'm doing. Now let's take a look at another capture that shows a call in progress. And so this time we're going to change the filter, and we're going to say or RTP or RTCP. Now here instead we've got, the phone's already registered at this point, and so now we're going to make a call. And so the SIP method that we're looking for there is the invite. And notice also that there's this other SDP protocol in here. That's the session descriptor protocol. Now we make a call. We say we're going to invite somebody. We're going to get this back and forth. The call server is going to tell me that it's ringing, and eventually the other end picks up. And we can see that in this case, in an Avaya topology, the RTP, that is the transport protocol, still goes to the call server. But what we'll notice is that where SIP is on a particular port number, now in this case SIP is using UDP, that's the Avaya way, but it's 5060 is the port number. But if we go to RTP, we have a completely different set of port numbers. And we had to negotiate a couple things here. We had to negotiate the port numbers that we were going to use, and you can see right here with G.711, the codec that was going to be used. So for SIP, the thing that does that is the session descriptor protocol. We can see all of the values that we're going to use are contained here in the SDP messages. And you have to do that for both directions. Okay, so we do our RTP, and this is where we are transporting encoded via the G.711 codec messages. And you can see that, when you get down to here, we can't actually read this. We would have to decode this. Now, as we go along, we're looking for RTCP messages. Now, the RTCP is a companion to RTP that is data about the data. So you can see there's a lot of RTP traffic here, and then all of a sudden, every once in a while, I get this RTCP. The port number is one more than the RTP stream, numerically one more, but it is data about the RTP stream. What information can we tell you about the phone call that's going on? This will be things like latency numbers, or at least timestamps, the amount of packets, the amount of octets, things of that sort. So we have lots and lots of details that are encapsulated in the various types of report that are generated from the RTP stream, the two ends of the RTP stream. Now, as we saw with option 176, we can put things like this or the TFTP server in a text string, or you could say, here's your TFTP server, go out and get the settings, or you could say, I'm going to just check the TFTP server for updates, and then I'll get information from my call server on the configuration for the VoIP network. Now, here is a sample of a DHCP pool that you might set up for VoIP phones. And we can see that there's a network out there and the default router. But here is how we might encode the options that we would use on a particular network. This is 176, and this gives us both the TFTP server and the call server address. Now, if we did option 150, then we're doing one of two things. We're either going out and we're getting a settings file, or the TFTP server is resident on the call server, and so we're going to pull down an XML file or something like that from the call server. Now, I showed you quickly the number of files that are necessary to support an Avaya. The Cisco is the exact same thing. So what you normally do on the phone is you say, here is the signaling protocol that I want you to use. And so the next time they boot up, they're looking for that information. So when they go out to the TFTP server, they might do an upgrade to that signaling protocol. So for example, if you have a Cisco phone and it was doing skinny and now you want it to do SIP, then you flash it over to SIP. And the way that you do that is that you tell it where the TFTP server is, and it goes out and pulls down all of the files that are appropriate for whatever signaling protocol that you use. Now, just like PCs, phones have a break sequence, so you can break into them and give them commands before they finish booting up. And they boot up because you plug them into a switch that had power over Ethernet. So just to review our process a little bit here again. If you have soft clients and we want to get away from manually configuring them, then the machine upon which that soft client resides is going to get its information from DHCP. You can have your clients be configured in a couple of ways. You could manually do it, or you could have a prepared client that is pre-configured with all the information, and then you just deploy it. Once the host gets an IP address, the soft client automatically gets an IP address as well. When you deployed the soft clients, they already knew where the call server was. The only thing that's left is the user logs in. When you have phones, they're just like PCs, right? They're a separate device on the network. Now, they might be hooked up in the same infrastructure as the PCs. In fact, you can plug a PC into a phone in a lot of cases. But when we use a phone, it's separate from the PC entirely. So it needs to get an IP address to operate on the network. It needs to power up via power over Ethernet. So you plug it in, it powers up, then it wants to do DHCP. Now, if your switch is not configured for port fast or something like that, then that DHCP can time out. That's another issue, a network configuration issue. But what are we going to learn from DHCP? Well, we're going to get our IP address and our mask and our gateway and DNS. But we also need now to know where a TFTP server is, potentially, if you're going that way, and certainly the call server. And so we've got a couple of options for that, right? We've got option 150, which is what Cisco does, option 66, option 176 on the Avaya side, and that might be the start of the next conversation. So then we go out to the TFTP server, we upgrade the phones, if necessary, we download our settings maybe, and then we're going to go out and register with the call server. And after that, you're ready to make phone calls. So while we said you might log into a soft client, you might also log into one of these. So you can log out of a hard phone as well, and some other user can log back in. In fact, one of the beautiful things about phones is that you pick them up, you move them, you plug them back in, and either the same user or a different user can use the same phone. All right, there we go. So this has been a little bit of VoIP infrastructure with SIP. So managing two phones is a lot different than managing dozens or hundreds or even thousands of phones, right? We have to worry about things like power over Ethernet, 802.3AF and AT. We have to somehow learn about the call server. Sometimes that's via TFTP, or we learn it directly from DHCP. And just for fun, when you're all set, you're ready to make calls, so you should see that SIP register, and after that gets a status of 200. You're ready to make calls, and you're ready to invite somebody. Well, thanks for watching. Thanks for listening. Like and subscribe if I helped, and may those SIP, RTP, TFTP, and DHCP messages always reach their destinations.